So right here we're dealing with a complicated piecewise function. There's actually 4 pieces on this piecewise function. We have a quadratic, which is a parabola. We know certain things about this parabola. It's opening down. The a value is -1, so it's opening down. It has a pattern 1, 1, 2, 4, 3, 9. It also has a h and k, a new vertex hk, which is -3 and -1. What else do we know? We know that this piece right here is a horizontal line crossing the y-axis at the value of 1. We know that this is a square root function, and we could think of the parent graph of the square root function, which is just the square root of x. And this is a linear function. You could think of it as y equals mx plus b. It crosses at -1 and it has a slope of up 1 over 1. And of course we have all these domain values for each of these pieces, right? So this parabola, we're only going to look at the piece of it that it has the x values that are less than or equal to -3. Anyways, we'll get to that once we graph it. Everything we do on this worksheet is going to be exactly what we do on tomorrow's test, but it'll be obviously more of it. So question number 1 says evaluate h of x when x equals -2. Well, it's as easy as this. You know you want to input -2, but where do we put it in? It depends on your restrictions. You're going to use the first one if the x is less than or equal to -3. Now, is -2 less than or equal to -3? No, it's greater than -3. -2 does fall perfectly between the -1 and the -3 on a number line. So we are going to be using this one to plug in -2. So the question is, where do I plug in -2? There's not even a variable there. So this one's so easy that you might get confused. The answer is 1. That's your answer for number 1. Because you know you're going to be using this one because -2 is between -1 and -3. So you're going to plug it in here, but there's nowhere to plug it in, so the answer is just 1. Moving on to the next one. It says h of -1. Well, where are we going to plug in -1 on this h of x function? Well, is -1 less than -3? No, it's greater than -3. Is -1 less than -1? No, it's equal to -1. And over here, it also doesn't have an or equal to, so we're kind of like, wait a minute, there's nowhere to plug it in. Since there's nowhere to plug it in, we have to say that h of -1 is undefined. There's nowhere to plug it in. It's undefined at that value. And we'll see that when we graph this thing, when we do go to the input of -1, we're going to see that there's a big hole right there. There's going to be no graph at the value of x equals -1. Moving on. Number 3, h of 3. So we need to plug in 3. Where do we plug in 3? 3 is not less than or equal to -3. 3 is not between those guys. 3 is equal to 3. So we're going to plug in 3 on this third piece right here. And if you plug in 3 right here, you could do this in your head. 3 plus 1 is 4. And you have the square root of 4 plus 1. What is the square root of 4? It's 2. 2 plus 1, final answer is 3. And just the way I did that in my head right here, you will be able to do that in your head on tomorrow's test. You don't have to show your work for those simple problems. h of 5. Well, we're going to plug in 5 where? 5 is greater than 3. So we're going to use this one. 5 take away 1. The answer is 4. Done. What do you think? We're done with about 25% of the test. That's the easy stuff. Now for the more fun stuff. Number 5 right here says graph the piecewise function. So we're going to take that h of x function that's above and graph it right here on this graph. So let's start with the first piece up there, which is a parabola. And I highly recommend that you use a pencil when you do this on your test tomorrow. Looking at the parabola up here, the h and k value is -3, -1. So my new vertex, if you want to write this on the side, your new vertex is -3, -1. You can put a V right there to remind you that that's your vertex. Okay? We know that it's opening down because of the negative sign, and we know it has the pattern because it's a -1 or +1 a value. It has the pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9 from the vertex. So these are all things that you don't need to write down, but you need to know them, right? So let's go to the vertex -3, -1. And if we go to -3, -1, we're at our vertex right here. And of course, through the vertex exists an axis of symmetry that'll help us reflect it onto both sides. I'm going to use the pattern 1, 1, 2, 4, 3, 9 from that vertex, but I'm going to be going down instead of up. And the reason why I'm going down instead of up is because of the negative sign in the front. So if I go 1, 1, I end up here. 2, 4, I end up way down here at that bottom corner. Everybody agree with me? Okay, now the thing is, do I do it over here, 1, 1, 2, 4, right? So do I complete this parabola, or let's look at our domain here. It says if x is less than or equal to -3. So -3 is right here, right through this value. X equals -3, and we want it to be less than -3. That's what it says up here. X is less than or equal to -3. So less than of this line is to the left or to the right? To the left. So you just want to see this piece of the parabola. You don't want to see this piece of the parabola. So don't even draw it. So we're just going to connect these guys, put an arrow right there, and we're done with that half or that piece of the parabola. Okay? Now, it is or equal to right here, less than or equal to -3. So this right here is a solid dot. That's why I didn't put an open dot there. Let's move on to the next piece. The next piece is 1. Now what does that mean? Think about that. It's like y equals 1. It's like if it said y equals 1. And if you think about y equals 1, what does that look like? Well, that looks like a line going right through 1 that's horizontal, side to side. Yay? Now the question is, I could start drawing it, but let me first look at my domain value. I only want the horizontal line at y equals 1 from the x equals -3 to the x equals -1. So from -3 to -1, just this piece right here, all right? Of what line? Of the y equals 1 line. So let me put my y equals 1 line right here. And let me put open dots on both of those. And then let's move on to the next piece. The next piece is a square root function. And it doesn't have an a value, so it doesn't get vertically stretched or compressed. But it does have an h and k shift. So the best thing to do is to understand your parent graph of the square root function first. And you probably want to do that by taking a look at y equals the square root of x, ignoring h and k, and getting the coordinates to that. So if I did do the coordinates of the parent graph y equals the square root of x, you'd think, what inputs could you plug in? You could plug in 0 into x because the square root of 0 is 0. You could plug in 1 because the square root of 1 is 1. And you could plug in 4 because the square root of 4 is 2. So those are your coordinates to the parent graph y equals the square root of x. There's 0, 0, there's 1, 1, and 4, 2 is right there. So we have those black dots. I could draw my square root graph through those black dots, but I'm not going to do that. Why? Because I still have an h and k shift to deal with. Now the h and k shift, I need to move 1 to the left. You need to think opposite on h and 1 up. So if I took this first dot and moved it 1 to the left and 1 up, it would actually connect it right there, okay? If I move this one to the left and 1 up, I'd be at this point. Whoa, it's kind of ugly. Right there at that point. And then if I move this one to the left and 1 up, I'd be right there. So we have this new transformed square root function that got shifted 1 to the left and 1 up. And it's always important to look and see if you're going to use open dots or closed dots. You're going to have an open dot at -1. So right here it's going to stay open. You see how it was open on the blue line and it's still open on this square root function. And over here it's also going to, actually this one's going to be closed at 3. So this dot right here is going to be closed. So let me connect it from the open dot all the way here to the closed dot. And that is our third piece. Let's move on to our fourth piece. Our fourth piece is y equals mx plus b. That one crosses at -1. Okay, let me go with the blue dots this time. It crosses at -1. And what do? my slope is up 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I only want to look at the values that are x that are greater than 3. Okay, so that's going to be an open dot that's greater than 3. So this blue line that I'm drawing right here, this blue line that I'm drawing right here, I only want the x equals 3 and greater. So that would be an open dot going this way. And that's it. That's my entire graph right there. What do you guys think? It's easy. All right, now, yes, but before we go back and explain that a little bit further, I just want to make sure that you guys understand that this is half a parabola. There's a big gap right here. There's a piece of a line, right, which is actually the second piece up there on the piecewise function. And then we have a piece of a square root function from this. And then we also have a piece of a line. This line started at -1. It went up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. But you only want to see the x is greater than 3. So here's your x is greater than 3, greater than's to the right. So you only show this piece of that huge blue line. You don't show any of this because you only want to see the pieces that are greater than 3, which is on this side. Right? So we have this 4-piece piecewise function, and I also want to mention that there's a gap right here, and that there's a gap over here, and there's an open dot right here. So this open dot, what that means, if we go back to number 2, it says if you plug in -1, your output's undefined. Yeah, because if you go to -1, there's a big hole right there, right? Now, if you went to 0, you'd have your output being 2. If you went to 3, your output would be 3. If you went to 4, your output would be 3. If you went to 5, your output would be 4. So right here, when you input the -1, you get an output which is undefined because there's a big hole right there. Anyhow, let's move on to the more challenging piece of this. The more challenging piece is this. I want you to modify the h of x function so that everything is connected. It says use the graph to sketch it first, and then state the new h of x function below. So in other words, what could I do to this guy to connect it? Well, I could move this half a parabola, move it up how many units? 1, 2 units, right? So how would we transform that parabola, or that half a parabola, 2 units up? What would I have to do if I wanted to transfer it 2 units up? 2 units up. Add 2 to that k value, right? So if I add 2 to -1, what's it going to be? It's going to be 1, right? So down here, my new parabola, it's hard to see. Down here, my new parabola will be negative x plus 3 squared plus 1. Now, it's on the first one. The pieces actually stay the same. Like, look, the first one's a parabola. That piece, the first one, is this first one right here. Cool? So I left a blank spot so you could just transform these guys. So if I were to have moved this one 2 up by giving that new k value, then it would be connected right here, which is what we wanted, right? Another thing, this one right here would also be nice if we could shift it 2 units up, or actually 1 unit up. So that would be going to the last one and shifting it 1 unit up, which would mean you'd add 1 to the -1, which would leave it at 0. So the last one should be y equals x, and that's it. So we're going to put an x right here, and that's it. And if you're wondering, what about the middle 2? Well, if we moved this one 2 units up and this one 1 unit up, then we really didn't mess with the line or the square root function, did we? So those 2 middle pieces are going to stay the same. And as you could see, I just wrote those in exactly the same. The 1 is right there. Square root of 1 plus 1 on the outside is right there. I didn't mess with those 2 middle pieces. I only shifted this 2 units up and this 1 unit up. So right here, you added 2, which changed it to a 1. And the bottom one, you added 1, which changed the k value to a 0. So it's just an x down here. I hope this helps.